The Boeing 747-8 is a wide-body jet airliner developed by Boeing Commercial Airplanes.Officially announced in 2005, the 747-8 is the third generation of the 747, with lengthened fuselage, redesigned wings, and improved efficiency. The 747-8 is the largest 747 version, the largest commercial aircraft built in the United States, and the longest passenger aircraft in the world. The 747-8 is offered in two main variants: the 747-8 Intercontinental for passengers and the 747-8 Freighter for cargo. The first 747-8F performed the model's maiden flight on February 8, 2010, with the 747-8 Intercontinental following on March 20, 2011. Delivery of the first freighter aircraft occurred in October 2011 and the passenger model began deliveries in 2012. As of December 2015, update, confirmed orders for the 747-8 total 121, comprising 70 of the freighter version, and 51 of the passenger version. Development background: Boeing had considered larger capacity versions of the 747 several times during the 1990s and 2000s. The 747-500X and 600X, proposed at the 1996 Farnborough Air Show, would have stretched the 747 and used the 777 derived wing, but did not attract enough interest to enter development. In 2000, Boeing offered the 747X and 747X stretch derivatives as alternatives to the Airbus A3XX. This was a more modest proposal than the previous -500X and -600X. The 747X would increase the 747's wingspan to 229 feet by adding a segment at the root. The 747X was to carry 430 passengers up to 8,700 nmi. The 747X stretch would be extended to 263 feet long, allowing it to carry 500 passengers up to 7,800 nmi. However, the 747X family was unable to attract enough interest to enter production. Some of the ideas developed for the 747X were used on the 747-400. After the 747X program, Boeing continued to study improvements to the 747. The 747-400 XQLR was meant to have an increased range of 7,980 nmi, with better fuel efficiency and reduced noise. Changes studied included raked wingtips similar to those used on the 767-400 and a sawtooth engine nacelle for noise reduction. Although the 747-400 XQLR did not move to production, many of its features were used for the 747 Advanced. In early 2004, Boeing announced tentative plans for the 747 Advanced that were eventually adopted. Similar in nature to the 747X, the stretched 747 Advanced used technology from the Boeing 787 Dreamliner to modernize the design and its systems. On November 14, 2005, Boeing announced that it was launching the 747 Advanced as the Boeing 747-8 design effort. The 747-8 was designed to be the first lengthened 747 to go into production. The 747-8 and shortened 747SP are the only 747 variants with a fuselage of modified length. The 747-8 was intended to use the same engine and cockpit technology as that of the 787, including the General Electric Gen X turbofan and partial fly-by-wire. Boeing said that the new design would be quieter, more economical, and more environmentally friendly than previous versions of the 747. As a derivative of the already common 747-400, the 747-8 has the economic benefit of similar training and interchangeable parts. Boeing firmed the 747-8 freighter's configuration in October 2006. The 747-8, as the current new development of Boeing's largest airliner, is notably in direct competition on long-haul routes with the Airbus A380, a full-length double-deck aircraft now in service. For airlines seeking very large passenger airliners, the two have been pitched as competitors on various occasions. Boeing states that the 747-8 is more than 10% lighter per seat and is to consume 11% less fuel per passenger than the A380, translating into a trip cost reduction of 21% and a seat-mile cost reduction of over 6%. Production of the first 747-8 freighter began in Everett in early August 2008. On November 14, 2008, Boeing announced a delay to the 747-8 program, citing limited availability of engineering resources within Boeing, design changes, and the recent strike by factory workers. On July 21, 2009, Boeing released a photograph of the first cargo airplane, its fuselage and main wing assembled. In February 2009, only one airline customer had ordered the 747-8 high-passenger model, and Boeing announced it was reassessing the 747-8 project. Chief Executive Jim McNerney stated that continuation of the project was not a foregone conclusion. The company was assessing various options. In October 2009, Boeing announced that it had delayed the first flight on the 747-8 until the first quarter of 2010 and delayed 747-8 high delivery. The company took a $1 billion charge against its earnings for this delay. In response, launch customer Cargolux stated it still intended to take delivery of the 13 freighters it had ordered. Lufthansa confirmed its commitment to the passenger version. On November 12, 2009, Boeing announced that Cargolux's first airplane was fully assembled and entering the Everett plant's paint shop. It was to undergo flight testing prior to delivery. On December 4, 2009, Korean Air became the second airline customer for the -8i passenger model, with an order for 5 airliners. On January 8, 2010, Guggenheim Aviation Partners announced the reduction of its -8F order from 4 to 2 aircraft. In March 2011, Korean Air converted options into a firm order for 2 additional -8 freighters. On April 21, 2010, Boeing Chief Executive Officer Jim McNerney announced that the company would be accelerating the production of both the Boeing 747 and 777 to support increasing customer demand. Flight testing and certification. The 747-8's first engine runs were completed in December 2009. Boeing announced the new model had successfully completed high-speed taxi tests on February 7, 2010. On February 8, 2010, after a 2.5-hour weather delay, the 747-8 freighter made its maiden flight, taking off from Payne Field, Washington at 12:39 PST, and landed at 4:18 p.m. PST. Boeing estimated that more than 1,600 flight hours would be needed in order to certify the 747-8. The second test flight in late February, a ferry flight to Moses Lake, Washington, tested new navigation equipment. Further flight testing was to take place in Moses Lake, conducting initial airworthiness and flutter tests before moving to Palmdale, California, for the majority of flight tests. so as to not interfere with 787 flight tests based out of Boeing Field in Seattle. By March 11, 2010, the 747-8F had flown 13 flights covering a total of 33 hours. On March 15, 2010, the second 747-8F first flew from Payne Field to Boeing Field, where it was briefly based before moving to Palmdale to continue flight testing with the first -8F. On March 17, the third -8F made its first flight and joined the test program. During the flight tests, Boeing discovered a buffet problem with the aircraft, involving turbulence coming off the landing gear doors interfering with the inboard flaps. Boeing undertook an evaluation of the issue, which included devoting the third test aircraft to investigating the problem. The issue was resolved by a design change to the outboard main landing gear doors. In early April 2010, Boeing identified a possible defect in a part at the top of the fuselage called a longeron. According to Boeing, the parts, manufactured by subcontractor Vought Aircraft Industries, are, under certain loads, susceptible to cracking. Boeing said that the issue would not affect flight testing, but other sources stated that the problem could impact the operating envelope of the aircraft until it is fully repaired. Two other problems have been found, with oscillation in the inboard aileron, and a structural flutter, and have not yet been resolved as of 2010. Combined, these problems have slowed flight testing and used up almost all the margin in Boeing's development schedule. On April 19, 2010, the second flight test aircraft was moved from Moses Lake to Palmdale to conduct tests on the aircraft's engines in preparation for obtaining a type certification for the aircraft. The remaining aircraft in the test fleet are scheduled to be moved to Palmdale during May. It was reported on June 3, 2010, that an engine on the second 747-8F was struck by a tug during a ground move. The engine cowling was damaged, but there was no damage to the engine itself. After repairs, the aircraft is to perform fuel efficiency testing. It was announced on June 14, 2010, that the 747-8 had completed the initial phase of flightworthiness testing and that the Federal Aviation Administration had given Boeing an expanded type inspection authorization for the aircraft. By the end of June 2010, the three 747-8Fs that composed the flight test program had flown a total of over 500 hours and had completed hot weather testing in Arizona. In June 2010, Boeing determined that a fourth -8F aircraft was needed to help complete flight testing. It was decided to use the second production aircraft, RC-503, to conduct the non-instrumented or minimally instrumented tests, such as HIRF and water spray certifications. The aircraft, painted in delivery customer Cargo Lux's new livery, first flew on July 23, 2010. On August 21, 2010, the 747-8F proved its capability by taking off from the runway at Victorville, California, weighing 1,005,000 pounds. Its design maximum takeoff weight is 975,000 pounds. The fifth 747-8F joined the flight test effort with its first flight on February 3, 2011. On September 30, 2010, Boeing announced a further postponement, with the delivery of the first freighter to Cargo Lux planned for mid-2011. The 747-8 passenger version took to the skies over Everett, Washington, for the first time on March 20, 2011. The second 747-8I flew on April 26, 2011. Three 747-8 Intercontinentals had taken part in flight testing by December 2011. The 747-8F received its amended type certificate jointly from the Federal Aviation Administration and European Aviation Safety Agency on August 19, 2011. Freighter deliveries were to begin on September 19, 2011. Then on September 17, 2011, Cargolux announced that it would not accept the first two 747-8Fs scheduled for delivery on September 19 in 2011. Due to unresolved contractual issues between Boeing and Cargolux with the aircraft. It entered service in October 2011. On October 25, 2011, the 747-8 flew to Grantley Adams International Airport in Barbados to begin flight testing in the tropical climate of the Caribbean to determine its effects on the aircraft. One test-8I was used for an evaluation by Lufthansa in early December 2011 before first delivery in early 2012. On December 14, 2011, the 747-8I received its type certificate from the FAA. The 747-8 has an airport quota count of 2 for takeoff and 1 for landing. Entry into service and future prospects. After resolving their contractual issues, Boeing handed over the first 747-8F to Cargolux in Everett, Washington, on October 12, 2011. The freighter then flew to Seattle-Tacoma International Airport and picked up cargo before flying to Luxembourg. Lufthansa received its first 747-8 Intercontinental on May 5, 2012, and began operating the version on flights from Frankfurt to Washington, D.C. on June 1, 2012. On September 15, 2012, the United States' National Transportation Safety Board requested the grounding of GE-powered 747-8s and 787s until engines receive inspections, following cracks discovered in 3 Gen X engines. On January 27, 2013, the 747-8 fleet reached the 100,000 hours mark. The 747-8 production rate was decreased from 2 to 1.75 aircraft per month in April 2013 and then reduced further to 1.5 aircraft per month in October 2013. On June 25, 2015, the Wall Street Journal reported that the order backlog was down to 32 and Boeing had decided to reduce production to 1 aircraft per month in 2016. In 2014, Boeing embarked on an improvement program for the 747-8 named Project Ozark, with the goal of improved range and lower fuel burn. With all improvements implemented, the resulting aircraft would have a maximum takeoff weight of greater than 1 million pounds. The company slowly introduced aspects of Ozark over time. An engine performance improvement package resulted in 2% lower fuel burn. Boeing also improved the tail fuel tank's function and improved the flight management software. Aircraft produced beginning in 2014 weigh 9,000 pounds less than the first 747-8 coming off the production line and burns 3.5% less fuel. Other improvements include revised fairings next to the tail and wing-to-body fairings. The chevrons on the trailing edge of the Gen X-2B nacelle were made thinner. Boeing hoped that these improvements, which benefit both the passenger and freighter version, would help improve sales. The future for the 747-8 passenger version seems limited. While airline pilots delight in flying the airplane and some carriers, like Delta Airlines, have found aging 747-400s to be iconic and attractive in advertising, demand for the airplane is likely to fade. Lufthansa Vice President Nico Buchholz stated Boeing has not marketed the 747-8 aggressively enough. However, veteran industry analyst Richard Abulafia of the Teal Group pointed to a basic misunderstanding of the 747's original draw. Airlines bought the 747 primarily for its range, not its capacity, and the potential for unfilled seats was an accepted drawback. The advent of the long-range twin-engine jet, exemplified by the Boeing 777, took away the range advantage. The increased capacity of the 747-8 is an advantage for the freighter version, not the passenger version. Moreover, the freighter has no direct competitor. Boeing Marketing Vice President Randy Tinseth acknowledges that the company has sold more freighters and fewer passenger versions than it expected. Boeing's 787 provides greater operational savings than the 747-8. The 747-8's large cargo space, coupled with the growing worldwide demand for efficient air cargo transport, suggests that the cargo version may have a strong future. Design. The 747-8 is a development of the Boeing 747 that takes advantage of improvements in technology and aerodynamics. The two 747-8 variants feature a fuselage stretch of 18.3 feet over the 747-400, bringing the total length to 250 feet 2 in. The 747-8 is the world's longest passenger airliner, surpassing the Airbus A340-600 by approximately 3 feet. With a maximum takeoff weight of 975,000 pounds, the 747-8 is the heaviest aircraft, commercial or military, manufactured in the U.S. Compared to the 747-400, the main changes have been on the wings, which have undergone a complete design overhaul. The sweep and basic structure has been kept to contain costs, but the wing is thicker and deeper, with the aerodynamics recalculated. The pressure distribution and bending moments are different, and the new wing for the passenger version holds 64,225 US gal of jet fuel, and the cargo aircraft 60,925 US gal. The increased wingspan makes the 747-8 a Category F plane rather than a Category E plane, similar to the Airbus A380. The new wing features single-slotted outboard flaps and double-slotted inboard flaps. Raked wing tips, similar to the ones used on the 777-200LR, 777-300ER, and 787 aircraft, are used on the new 747 variant instead of winglets used on the 747-400. These wingtip structures help reduce the wingtip vortices at the lateral edges of the wings, decreasing wake turbulence and drag, and thereby improving fuel efficiency. Another effort to reduce weight is the introduction of fly-by-wire technology for the majority of the lateral controls. The extra fuel capacity in the redesigned wing compared to the 747-400 eliminates the need to significantly change the horizontal tail unit to accommodate auxiliary tanks, further saving costs. The 747-8's vertical tail unit is largely unchanged with a height of 63 feet 6 inches. Some carbon fiber reinforced plastic is used in the 747-8's airframe to reduce weight. The General Electric Gen X is the only engine available for the 747-8. It is one of the two power plant choices offered for the Boeing 787. The flight tests of the Gen X-2B engine fitted to a Boeing 747-100 aircraft at the left inner engine began in March 2009.